Good afternoon, everyone. My name is Nienhuis. I'm a product manager on the Databricks streaming engine team. I also work a little bit with DLT and open source Spark. And today we're going to be talking about one of my favorite topics, expanding DLT such that we can read and write data from virtually anywhere. So we're going to go through kind of where we're at today. I'm going to walk through a lot of different code examples of what's possible right now, and then I'm going to give you some sneak peek with some code examples of what's going to be possible in the near future. So let's get started. So why does interoperability matter? Traditional ETL pipelines, they typically work on ingesting data from a variety of sources, and then go through various steps like using the medallion architecture in getting to your gold tables and then serving your data. However, this is where DLT historically started at, right? We'd ingest data into maybe a raw table, write data to a series of streaming tables, and maybe end in a materialized view. However, one of the biggest pieces of feedback that we've heard over the last couple of years with DLT is that I have additional use cases that don't follow that simple architecture. I do a lot of reverse ETL. I need to get data into and out of Databricks, and your world, your data engineering world, is not all the Lakehouse. So how can I do that more easily? Use declarative, easy-to-use service. So in this talk, we're going to talk about how we fixed the majority of that problem, and how we're going to complete our vision of making that having DLT having basically the same parity of ecosystem, and maybe perhaps even better than Spark Batch and Spark Structured Streaming. So I think you all know Apache Spark is integrated everywhere. I mean, there's hundreds of different connectors, hundreds of different partners that are built on top of Spark. If you want to process data with Spark, the world is your oyster. There's a plethora of things to do. There's, over the last even 4 or 5 years, we've modernized a lot of the data sources and sinks. A lot of the most popular integrations, like the JDBC integration, have been redone to be both simpler and more feature-rich. We support across Spark is supported very well across all the cloud providers. But there are some limitations. As we grew, there was not a lot of uniformity across the connectors. So different connectors were supported in different languages. Depending on your environment, you may or may not be able to use a connector. For streaming specifically, streaming really relied heavily on ForEachBatch and using that construct with batch connectors to spread out the ecosystem and work for supports, which was it's a very powerful operator and very flexible, but it's not that easy to use, and there are some limitations on latency for it. So how do we bring parity to this? How do we bring and kind of modernize our connector ecosystem with Spark, as well as make it simple to use on Databricks and within DLT? So I'm going to go through kind of a history of where we started and where we're going to end up. So when we launched structured streaming, we first launched just the foundational integration. So like file system streaming, support for Kafka, initial support for Kinesis as data sources, and they were really focused on ingest. All right, so all of the message buses support were really supported on data sources, and then you write to your Lakehouse, your file system object storage, so on and so forth. Most of these connectors were first built using data source v1. Data source v1 was like the initial primitive for most of Spark's integrations. Some of them have been rebuilt in data source v2, which was shipped within several years ago. But it's taken a while for those connectors to modernize. After that, we started getting as Spark took off, we started getting widespread community support. So Cassandra, Azure built a CosmosDB connector. MongoDB built a streaming native connector. And you saw that ecosystem expand, and depending on when they implemented it, they might have feature X or feature Y. So this led to disparity of feature set, of security and performance, and so on and so forth. About 4 or 5 years ago, we started project, it says 2023, but it was around probably 2021, 2022. We started Project Lightspeed, which is basically a marketing term of we're reinvesting a whole lot into structured streaming. as part of that, one of the focuses was on interoperability and integrations. So we built basically message bus sources for almost all of the message buses, so Pulsar, PubSub. We redid our Kinesis connector, upgraded our Kafka connector, integrated with schema registries. We built the Kafka Sync and upgraded the Kafka Sync. We made sure that the write stream and read stream from Delta was highly performant. And that's kind of where we are today. And today, for like the core use cases on Databricks as well as in the OSS ecosystem, we do pretty well, all right? But like I mentioned on the first slide, not everything is Lakehouse native. Not everyone only has ETL and ingestion use cases. So if I need to write to my Postgres database, how do I do that? There's 3 different ways right now in open source and on Databricks to do so, with different JDBC drivers, a Postgres-specific driver, so on and so forth. And then depending on what product you're using, it becomes even a little bit more confusing in the fact that some products like Classic, Compute, DBR, and Jobs supports a set of connectors, and DLT supports a different set of connectors. So how do we make this simple, both in the open source community as well as on Databricks? So the next couple of slides are going to talk about some primitives that we've built over the last couple of years to help simplify our story. One of them you may be familiar is Apache Spark Connect. Apache Spark Connect provides secure infrastructure and connections to a lot of the integrations I mentioned. And when we shipped this, there was limited support for a lot of the streaming connectors, and over time we've added more and more. But the goal here is that you can have very easy security, things with like credential rotation and stuff like that, as well as governance over your integrations within Databricks. So Databricks manages the connectors to like tables and files. It manages external connections such that when a user wants to read from a particular Kafka topic, they simply use an external connection within UC. This is all that Apache Spark Connect unlocks. What I'm showing here kind of demonstrates the evolution of the ecosystem within Spark. So this is a Postgres SQL driver connecting using the data source v1 API. It's still widely used across Databricks. It's one of the most popular databases for you to integrate with is Postgres. And even though we shipped like a brand new JDBC connector in open source as well on Databricks in March, that it went GA, all right? A lot of customers are going to take a while to adopt that JDBC driver and switch all of their queries, all of their batch jobs, all of their structured streaming jobs to it. So, with this API, how do we make sure that customers can use the products they want to on Databricks using the older connectors while they upgrade to the newer features and functionality? To know, and this is definitely something you want to do. You want to be able to upgrade because the new integrations, first of all, they're built on data source v2. A lot of them have advanced performance features like push down filters and things like that you can take advantage of. They're more stable and scalable, but it still might take you some time. So the next 2 slides are going to paint a pretty, I was going to take this, paint a pretty picture of kind of where we are today and then where we're going to be in the very near future. And you can kind of see where I'm bringing up, depending on whether you're using serverless, standard or dedicated clusters, or DB SQL, you have a different integration story. For all intents and purposes, that standard slide is DLT, effectively, because DLT runs on standard clusters. So we support reads and not writes for serverless on JDBC connection. On standard clusters, you can use certain drivers for MySQL databases and JDBC, but you have to give any file permissions, so there's a question mark there. And there's a lot of no's across the board here. Notably, the last line, the Python data source, which is a brand new, which I'm going to go through a code example later in this presentation. So it's shipped last year, and we're going into GA in the next month or 2. But notably, that's very recent, and as such, it has yes across the board. But how do we bring everybody else and all of your legacy implementations up to speed such that you can use DLT, such that you can use serverless? How do we support a much broader set of use cases on DLT, more than just ingestion and ETL to gold tables and to DB SQL? How do we support operational use cases like real-time analytics, reverse ETL? So this slide reflects where we are likely to land at the end of the year. So almost all of the bundled and unbundled connectors will be supported on serverless, standard and DLT, as well as dedicated. You'll have a consistent experience where you can use the same features across these product lines. So if you have a structured streaming query running on jobs in DBR, the connection experience is going to be very similar to what you experience at DLT. It won't be this like non-parity feature set that we have today. In addition to that, there'll be very few limitations. Even the DB SQL, I have the 2 asterisks on there. We think we're going to be able to support read-only, but we're working also on write as well. So DLT declarative connectors. I went through this, kind of hinted at it in the earlier slides, but we started, the focus of DLT was to make the most common data engineering patterns as simple as possible. So ingest into a streaming table, which abstracts a lot of the complexity of managing your own catalogs and schema and stuff like that. It's defined declaratively within the pipeline. Go through a series of steps to gold tables. We did start out ingesting from virtually every structured streaming source, but this was primarily like the native built streaming connectors that we have built in. So if you wanted a custom connector, we didn't support that. So it really, because of the lack of interoperability and integrations, it really only focused on the ingestion and ETL use cases into your data lake. So where we are today, with the features that we have in public preview that are production ready, is we have a lot more robust for data sources, including custom data sources that you can build using the PySpark data source API, so native Python custom connectors. We have UC service credentials working for all of our message buses. That means that you can share, and I'll go through a code example on this. It means that you can very, very easily manage your connections in DLT to your Kafka topics, to your Kinesis streams, to PubSub, to Pulsar, so on and so forth. You don't have to hardcode any credentials. We handle credential rotation and everything like that out of the box. And it's very easy for you to start up and share those credentials across your team using permissioning and governance through UC. In April or May, we shipped public preview for a new API called the Sync API. The Sync API, the purpose of that API is to give full parity of all syncs in structured streaming and Spark to DLT. So right now in public preview, we support Kafka as a sync, UC managed tables, and UC external tables. In private preview, coming to preview in the next month, we have ForEachBatch, all right, I'll go through the use cases if those are not familiar with it. And we support in public preview going to GA very soon Python data source, so for custom syncs. A lot of our essays have built some incredible things using the Python data source and written some blogs at the call to action at the end of the slide. I'll link you some, but custom syncs to DynamoDB, to Redis, to so on and so forth. Whatever you want to write to, it's a very simple implementation using the PySpark API to write to it. So virtually getting data anywhere. So what's possible today? So I kind of gave an overview. The next part of the talk is just like heavy code examples, all right? We're gonna walk through like what these new APIs look like, what's available, what's exactly available today, what's coming in the near future, and the advantages of each of these approaches. So the examples I'm gonna go for are using UC credentials with message buses and how simple that is. I'll go through the overview of the DLT Sync API, and using that API to write to any of the Delta tables. And I'll go through the advantages and disadvantages of each. So the advantages of using a streaming table, what you might want to use there, versus if you want to write to an external or a managed table, why would you want to do that? I'll go through it says customer PySpark sync, my mistake, but I'll go through a custom PySpark sync, writing to Splunk. And we'll go through writing to custom integrations, particularly a fan-out use case using ForEachBatch. So writing to multiple destinations from the same flow. So you see creds with your message buses. This is perhaps, so we just launched this like 2 weeks ago ahead of DAS. Like we're still updating the documentation, so it's really fresh. It's in public preview. This is perhaps one of the features that I'm most excited for on DLT because it really simplifies security and governance, all right? Walking through the code on the right-hand side, we see we have a table named for Kafka ingest, all right? And I have a read stream with my like normal Kafka options set up. And then if you go to the last options, you see I'm using a Databricks service credential with a UC cred name. And in there, you can put, Confluent credentials, MSK credentials, GC, like, if it, not relevant for Kafka, but any of your cloud credentials basically can be used in that, and we will rotate them, integrate with IAM for you out of the box. And then when you want another developer to go build another use case, this isn't go set up an IAM role again, get it to work with Databricks, make sure it's loaded, or hard code credentials in your code or anything like that. It's simply give them access to the credential and they'll have access to the external connection via UC. So it drastically simplifies that connectivity process of getting data from your message buses. Our goal here is to support these credentials wherever it makes sense across the board. So we've made it, these work, and some of the other connectors we'll work on next. DLT Sync API. So this is an API we worked on, like we had a private preview starting in December of last year, and we went public preview, I mentioned say like around April. And as I mentioned before, this is the mechanism in which we're going to provide declarative syncs and integrations to you across and get parity with structured streaming and Apache Spark. The API is very, very simple. You create a sync. That sync can be used across your pipeline. So it's isolated to the pipeline. We don't reuse syncs across pipelines or across workspaces. You define a sync here, but you can reuse the connections in UC, as I mentioned. And then you basically attach an append flow on it. Very simple code of your name and then your target on the whatever sync you created, and your normal DLT code, all right? So I would consider syncs, this is like a new first-class concept in DLT, all right? Similar to streaming tables, materialized views, and views, this is another option to construct your pipelines. So you can do basically everything here. I mentioned, we'll cover some other examples, but you can put JDBC Sinks in here, DynamoDB Sinks, so on and so forth, using the PySpark Python data source API. So let's go through a specific implementation of the DLT Sync API. This is the slide says writing to any Delta table, but this allows you to choose, based off of your use case, whether to write to a streaming table, whether to write to an external UC manager or UC external table. So first, before I go through the code, why would you want to do this, all right? Like, why wouldn't you just use streaming tables? There are significant advantages to scoping and defining your data with your code base and versioning the data with your code base, all right? It's easier to manage, especially if it's scoped down to just your pipeline. So if I were to simplify the recommendation of when to use a streaming table, it would be if your data processing can be confined within the pipeline, use streaming tables. That is your best bet. You'll get incremental processing. You'll also get advanced features like expectations, apply changes into, so on and so forth. However, if you need to work across many different workspaces or pipelines, or you need lots of external connectivity, or you want to manage your catalog and schema independent from your code, streaming tables prevent that. The DLT Sync API allows you to have, depending on how you've set up your data platform within your organization, it allows you to, if you want to manage the schema and catalog outside of DLT, go ahead. If you want to do some things in streaming table and some things using Delta managed tables, you can. The great thing here is you can go back and forth too. So you can have a pipeline with a flow to an ST, a flow to an MV to an external table back to a streaming table. And this is especially important for external readers and things like that. It also is working across organizations, depending on where they are on their UC journey, where they're on their adoption of DLT. It might make sense to use exclusively, managed tables or exclusively external tables. But the point is it gives you the flexibility. So going through the code, as you can see, I'm using a fully qualified name to mention the table, which is the best practice. And it's a very simple append flow with a simple expression. So previously, like one of the most common reasons pain points customers had is, how do I get data out of streaming tables, all right? So what they would do is they'd run a structured streaming job to basically read from a streaming table and then write to an external table as a copy. It's like wasted processing. And you'd have to use a completely different tool. So there's a product cliff there. You no longer have to do that. All right, custom PySpark sinks. So this is an open source API that was designed specifically for Python developers to build custom integrations. All right. So I mentioned two other APIs and interfaces, Data Source v1 and Data Source v2. These were, they're very, very full-featured interfaces to build custom integrations, but they're very, Scala, Java, heavy. So if you want, to write a simple Python integration, you were stuck using a primitive, you couldn't do something reusable. This new functionality allows you to get away from that. So, for example, you build this PySpark sync once to say some REST endpoint you're writing to, as one simple example, all right? We have Splunk here, all right? You build it once, and that code can be reused through your CI/CD and code repositories across all of your pipelines very, very simply, and you do it once with a shared code base to help enable interoperability across your organization. So this was available in open source for a while, but now it's official released in Spark 4.0 and DBR 15.4. You can use it for both data sources and data sinks. So you can build custom integrations on data sources as well as sinks. It's not necessarily that relevant for DLT, but you can run batch. You can also build batch integrations with it. The example I have is a very, very simple push to Splunk. So imagine you have a DLT pipeline. Your use case is, I would like to perform some analytics, some massaging of my telemetry data, all right, before I forward the data to Splunk. Namely because I want to filter and aggregate data so I don't spend however much on my Splunk bill, right? Good use case to get telemetry for security data and everything like that. Now is very, in a couple lines of code, very simple to implement on DLT. And this is a very, very different from the use cases that we started with on DLT, the ingestion and ETL. So the point of me showing Splunk specifically is that DLT with these changes, including this one and the other things I'm presenting today, is now viable for a much more broader set of data engineering challenges. Another one of my favorite, actually just out of curiosity, a show of hands, who knows what ForEachBatch is and or has implemented it before? So not a huge portion of the room. All right. So ForEachBatch is a primitive that is a very, very powerful primitive, all right, that has been used in structured streaming for a while to support a number of use cases. When we did research last year to figure out what the most popular use cases for ForEachBatch were, they were the following. So custom merges into Delta, all right? So things like fanning out, reading from a data source that has multiple different row types or event types in it and fanning out to n different Delta tables, all right? Doing a custom merge based off of your own logic, writing to multiple destinations. So one customer I know writes to Delta, use it, and also writes to CosmosDB in the same connector. The other and final use case that it was most popular for was basically it gave you access to every single batch integration, all right? So if there was a batch connector that you wanted to reuse, you could now use it in the streaming context. So you'd have your streaming pipeline, and this ForEachBatch sync is effectively like And then we're going to run this mini batch job on the data you just processed. And you could reuse any connector within the much broader set of batch connectors within a streaming pipeline. But there's a catch with this. So it's not like this be-all, gets-all thing. It does solve, it's a very flexible, powerful sync, but issue is that there's limited housekeeping and state management. You control that on your own. It's a lot of custom code to write. You don't get expectations with it in DLT, and there's very limited telemetry. So you're going to have to publish your custom metrics, like how many records you wrote out or things like that. So very, very powerful. Gives you access to a lot of different functionality, but there are definitely some trade-offs. It's not a perfect solution. But the best part about this for DLT users is that we apply changes into is a very, very, very powerful piece of functionality, all right? If it works for your use case, it's cost effective, all right? It's fast, it does incremental processing, and it's great. But what happens if that doesn't work, all right? And there's a set of use cases and reasons why apply changes into, and we're always proving it wouldn't work. The product cliff would be you'd have to go use structured streaming or copy the data and do something else, maybe run a batch job to do the merge after it. Now, with an introduction to this functionality, you can perform things like fan out and merges within DLT without switching products. The final thing I want to mention is with this connector, when we go to public preview, and actually in the private preview now, we support full refresh support. So one of the other reasons why people like to do custom merges with ForEachBatch is because they like to manage their own idempotent merges. So like if they have to reprocess data or anything like that, they want to manage how that occurs, all right? This allows you to do that with this operator, and it's fully supported. So if you do a full refresh on a DLT pipeline that uses ForEachBatch as a sink, it works seamlessly. So I went through what's available for you to try out like today, all right? I'm going to go through where are we going, and I'm going to be pretty explicit about timelines on things that we're going to be supporting. One of them is the merged use case that's upcoming when we go to public preview. So I mentioned ForEachBatch and custom merges. Here's a good example of what that would look like. So you kind of get the way I like to think with the changes we're making here with DLT is we are declarative first, but we allow you to bump out into imperative if you need to, all right? So we're declarative and simple first, but if it doesn't work for you and you need fine-grained control over how things happen, here's an example of how you're able to do so. So this is a ForEachBatch sync. You can see that I am, let me read this. You can see that I'm doing a merge within that sync with specific conditions on that merge, all right? And what's going to be coming soon is what I'm very excited about, which will simplify this use case significantly, is DLT will support update flows, all right? Meaning that instead of just being able to append data to it, we will support the update output mode in structured streaming. This is very important for especially stateful stream processing, and I'll walk through a use case of why. So imagine from silver to gold, you're doing an aggregation, all right? And in that aggregation, let's just say it's a sum or min-max or whatever, all right? You're performing that aggregation, all right, and then writing it out to the destination table, all right? With append, you set your watermark and you'll get a single result, and if any data arrives late, it gets dropped. You don't get updates, especially, so you're forced to make this trade-off on latency or completeness that's very like bipolar, right? You can choose a short watermark and prioritize on latency to append the data with that stateful aggregation as quickly as possible. But then any data that arrives late, you'll drop. Or you can choose a very long watermark in an append flow. And when you choose that very long watermark, what will end up happening is the data, let's just say you say an hour or 2 hours or 6 hours or 8 hours. A, you're going to use a lot more resources in state and memory to do that computation, all right? And B, you're only going to get that output once, and it's going to be however long the watermark is delayed, all right? Append flows are very, very powerful and simple. They don't fit all the use cases, and they don't provide a good trade-off on latency and completeness. Update flows solve that problem. So update flows, instead of getting a singular result at the end of the watermark, we will give you intermediate results up until the end of the watermark. So you have an aggregation. The first time we have this aggregation, we send it downstream. If we receive new data, we update the computation and send kind of like an amendment downstream, all right? So we do this continuously until the end of your watermark. So the watermark effectively becomes almost like an allowed lateness value, where you can still get the latency, but have a lot more complete results. Why this is so relevant to merge use cases, if it's not self-evident, let me just spell it out a little bit more clear. It means that if you design with like a ForEachBatch for your merge to be like idempotent on this, you can get continuously updated fresh results with a very little code just by setting it to update and then just doing upserts into as based off of your merge based off of a key. And the powerful thing, this won't work with just Delta. This will work with Postgres databases, MySQL databases, so on and so forth. The green slide that I showed up, that grid, you can do this type of processing with low latency, with completeness across a vast array of destinations using DLT now. So this is coming, this is available in the preview channel today. I want to caveat that because we recently rolled back the preview channel from 16.4 to 16.1. I still think it's available, but I'm not, but it'll be available soon if it's not available in the preview. It's been available for a couple months now in the preview channel. It'll be available in public preview sometime in half two. Hopefully Q3, but we will see. Run low latency operational use cases. So this is a brand new piece of functionality that I think we'll announce on the stage tomorrow, that we're open sourcing it, but the SPIP is already out there in the dev and user thing, but it's a new trigger type within structured streaming. For those more familiar with DLT, you kind of have two trigger types. You've got continuous and like scheduled or triggered, right? The underlying structured streaming primitives that those use are two trigger types called available now, which processes all the data that's available now, and then a processing time trigger, which will run the query continuously based off of some fixed interval, be it like 0 milliseconds or 500 milliseconds. It'll just keep on processing based off that interval. This is a new trigger type where you specify, as you can see, real time, all right? And what it provides is continuous processing over and enables data to seamlessly flow through the app and send results out immediately, all right? So unlike a traditional structured streaming job where you schedule your job and one stage occurs and then another stage occurs, reading from memory, and then it writes to memory, and then another stage occurs, so on and so forth. What happens is data flows seamlessly through the tasks at low latency. So we shared last year in early stages POC, and we have other talks where we're sharing where we're at with the latencies, but we now have customer vetted latencies on this that they're hitting median latencies in the tens of milliseconds, all right, and P99 latencies for the very complex multi-operator use cases in the hundreds of milliseconds. So why does this matter? Again, with DLT, we started with primarily support of ingestion and ETL. With support for this, all right, you'll be able to run basically very low latency operational use cases. So think Kafka to Kafka, not hitting Delta, Kafka to a database, Kinesis to Redis. So if you have use cases where, like, for example, you want to read clickstream data in near real time, all right, process it, and then give a live recommendation back to your customer, you can do that. At a point in sale, if your customer's in your store shopping around and they're using your app, you can send them a notification for a discount code, all right? It opens up a brand new set of use cases and potential business value with this trigger, and this will be available in DLT, as you can see with the update flows, sometime in the second half of the year. This feature will first be available in Classic and standard clusters, but DLT will come very soon. Public preview for Classic on DBR is going to be right around August, all right? And the final point about this, this trigger type, what's very, very cool, is similarly to going from a triggered to a continuous job very simply, you'll be able to go to this real-time trigger mode with like kind of a flip of a switch with no changes in code. So if you have a super efficient triggered streaming job pipeline that is running in DLT, that's running once an hour, And then your business comes to you and says, we want that to be real time. We need it faster. We need it faster. You're talking about like 1 or 2 config changes, and you're moving from once an hour to sub-second processing, all right, with no other changes. So very, very powerful. On the other flip side, if you implement an operational use case and you're like, this is valuable, but we really could use the efficiencies of just doing this once an hour, you can go the other direction. So the power of moving with this like latency kind of bar on where you need to be is with simple config changes is what this unlocks. So we're coming up to the end of my presentation. I think the point I'm trying to convey here is that with the changes we've made already, a vastly new use cases are now implementable on DLT, especially reverse ETL use cases, different types of merges and things like that. And within the next couple months, you'll be able to implement a much wider variety of use cases, basically to serve almost all of your data engineering needs using DLT. Our goal is to have full parity with structured streaming on DLT. There's other things we're doing around monitoring, around ability and things like that, around like loading custom libraries, other things like that we also are doing with this, but this is probably the most important, is making sure that interoperability and integrations are the same regardless of what product you use on Databricks, regardless of what type of use case you want to implement. The other area we're going is we're going to start building more native integrations. We're still figuring out what we're prioritizing. By far, the most popular customers have asked for are native JDBC sinks, so a native streaming sink that's a low latency write to, say, your Postgres database or any JDBC or Lakebase, any of your JDBC integrations. NoSQL databases come up a lot. And then the final one is the write optimized Delta Sync. So our Delta Sync is really it's really, really configured and set up to make sure you get very good read performance, and we save on object storage costs, right? However, there are a lot of customers that, my business keeps on asking me for lower latency. I can deal with the smaller files, the increased object storage cost, or I'm using some version of object storage that's cheaper that I can get high throughput writes on. I want to write as fast as possible. That's another native streaming integration that the customers have asked for. So I'll go through this slide a little bit more quickly, but governance and security everywhere. We did this for message buses, and we've done this for a number of batch connectors, but our goal is for you to be able to manage these integrations using UC, all right? So you don't have to ask a data scientist or an engineer to file a ticket to go to your security team to get a new IAM role and to give that person permissions or that workspace permissions every single time. You just manage it through UC. And through secure infrastructure using Spark Connect, as well as us handling the the credential rotations and everything like that. So all the action, I borrowed really heavily some very smart people for some of these slides. They're Allison Wang, who is the tech lead on the Python data source. She has awesome examples on that GitHub repo for it. Alex Ott has 2 great blogs that were written in the last couple months that cover the ForEachBatch stuff, Python data sources, and how to use it within DLT. So step-by-step code examples, walkthroughs. And we saw a lot of this stuff is coming in hot and fast with a high velocity. We'll, in the process of updating our own documentation, doing as many examples as we have. And finally, and I'll end with 1 minute of Q&A. Please fill out your surveys. It helps us out. Let us know what talks to prioritize next year. So really appreciate all your time. And for right now, I'll just take some questions for the last minute.